All right, my phone ran out of storage, so I've had to do a take two of this question. So this is a continuation of the last video on polymers, so looking at the exam questions. So I think it cut out right at this exam question, and I start making some notes, but I'll talk through those with you now. So any point in time when I put up an exam question, if you want to pause the video and try it on your own first and then come back and see how you've done, I do recommend that because it's good practice for you. But let's take a look through this. So it's actually a continuation of a question. I took the rest out because it wasn't related to the polymers. So this part, it says in a separate experiment, the chemistry teacher prepares compound E from 2-amino-propan-1-ol. Okay, so there we go. And anytime you get a question like this, it's a new molecule, you've never seen it before, and it seems a little bit daunting, just break it down and take a look at the functional groups that are there. So that's what I've started circling. So we have this functional group here, your alcohol, this one here, where hopefully you now recognize as an amide. So your carbon double bonded to an oxygen, also double bonded to an NH, or amino in the name, amino related to amino acid, peptide bonds, so peptide, amide, same type of bond, or same type of functional group. And then this one here, your benzene ring with an OH is your phenyl. All right, so that will always help you tackle a question, whether it's a synthesis question or whether they end up asking you questions related to different parts of the molecule. It will always help you at least start to think about the starting point to tackle a question related to a molecule like this, or a molecule you've never seen, because you will be asked about molecules you've never seen. They want to test that you know about the functional groups, irrelevant to the compound, so irrelevant to whether or not it's a compound you've seen or not. They want to know that you know what happens to the functional groups. Okay, so the first part of the question, one of the functional groups in compound E is phenyl. Name the other functional groups. Well, we've already identified it. So amide and alcohol, you'll have to mention both. You'll have to write both down to get that mark. Okay, next part, draw the structures of two organic compounds formed when compound E is heated under reflux with dilute hydrochloric acid. Now with this, we have the two potential functional groups that could react, the alcohol or the amide. So if we look here, your alcohol, we have phosphoric acid in reflux, you get your alkene. So we do have acid reflux forming an alkene. However, your dilute HCl is really not going to be enough for that reaction to happen. Like phosphoric acid is a pretty strong acid, okay, and it doesn't say dilute, so this doesn't happen under dilute acid conditions. The amides, we do have them here, but we only have them in relation of forming your amide from an acyl chloride. So we have to think back to the video that I had just done talking about the hydrolysis of your amides. And you have acid and you have base hydrolysis. So here we have reflux with dilute hydrochloric acid. So this is acid hydrolysis. So we're breaking the amide bond. We're breaking that linkage there. And it will break here, so you get your carboxylic acid again and you get your amine again. Now this is under acid conditions, so you do have to remember that nitrogen, you'll end up with NH3+. as one of the products. So let's start with drawing that one. So that will be a plus. And then we have that bound to a carbon, which is bound to a CH3, and then goes to bind to another carbon when we then have the alcohol group. Okay. And then if we look at the other part of the breakage, where the hydrolysis takes place, you have your carboxylic acid that will form. And under acid conditions, you do just get your carboxylic acid, so your C double bonded to your O, bound to your OH. So for drawing purposes, I'm going to draw the phenyl first, just because for myself that is easier. Then we have your C double bond to the O, and C double bond to the OH. Okay, those are your two products. So hopefully that's not too bad. So our next question, okay, again quite small, so I'll read it out. Salicylic acid can be used to form a condensation polymer similar to terylene. Explain what is meant by the term condensation polymer. Okay, so we talked about this at the beginning of the last video. You have to mention monomer. They form bonds. And you have to mention the small molecule for this specific example, because we have carboxylic acid and alcohol, it's water that forms. So monomers form bond and water forms. So important that you mention the monomers forming bonds and you're also forming water, okay, to get that 1 mark. So the next one, the repeat unit of terylene is shown below. Draw the skeletal formulae for 2 monomers that can be used to form terylene. All right, so we're looking for condensation polymer. We can hopefully notice here we have an ester link. So this is where we're going to have our 1 monomer on that side of the ester link and our other monomer on the other side. So we had a dicarboxylic acid and a diol. So let's start with the first monomer with the dicarboxylic acid. So that is breaking, which means we will have an OH. I'm going to show a bond just because I drew those a little far apart. Okay, and that benzene ring, and then the carbon bond to OH. Okay, so we have that 1 monomer, and then our diol. Oh, I'm going to redraw that because I made the mistake. It says a skeletal diagram. So OH that's our carbon with the oxygen double bond. There we go. Okay, so it did say skeletal diagram. So redrawing that, and then we're drawing, let's start with the skeletal diagram of this other monomer. So we have 1, 2 carbons, and then another OH. So I'll cross that one out, just so, and I would recommend that if you make a mistake, cross out the wrong answer so examiners don't get confused of what your right answer is. So those are our 2 monomers. Great, so next question, or next part of that question. Move it up. Salicylic acid reacts with 3-hydroxypropanoic acid to form a mixture of condensation polymers. So this actually continues on a new page. To form one polymer, two monomers react in equal quantities. Draw the repeat unit of this polymer, displaying the link between the monomer units. So we do have salicylic acid given to us. So I'm actually just gonna redraw it so we know what the monomer is. We know what we're working with. Okay, and let's draw the other monomer that we're working with. So the 3-hydroxypropanoic acid. So propanoic, prop, 1, 2, 3 carbons. The first carbon is where we have our carboxylic acid group. Don't be too annoyed with me that I'm drawing first carbon over on this side. And then the 1, 2, 3rd carbon has an OH group. So hopefully that didn't throw anyone off. Okay, so that's our two monomers. And we want to form the polymer and the repeating unit. So I'm going to take that page away because we have everything we need on this page now. All right, we now have to think about what's going to take place between these two monomers. So we have our alcohol group, that OH, or that H from that alcohol group will leave with that OH from the carboxylic acid. So between this carbon and that oxygen is where we're going to form an ester link. Okay, which means that hydrogen will leave and we'll have our chain continuing with that oxygen there. And on this side, this OH will leave and we'll have our chain continuing with this carbon there. So let's draw that out. So I'm gonna turn this, rotate that around a little bit. So we have our O continuing. There we go. Our C is here. We're going to link it to that oxygen, which is then bound to 1, 2, 3. 1, 2, 3. I'm going to draw that C2, and that's where we're continuing. Okay, so we've shown our ester link, and we've shown that our chain continues on that carbon there, and it will continue on that oxygen there. Okay, now this is a combination of skeletal and display, so potentially just redrawing that so that I'm not going to bother drawing our benzene ring anything other than a skeletal, but the rest you could show the atoms. And if you're doing that, you have to remember to also show your hydrogens. Okay, all right, so either or. You could potentially draw this whole thing as a skeletal, but with showing that the chain is continuing there, I like to show that carbon atom. Alrighty, so that's that question done.